To the previous speakers for setting the stage and introducing already the post-AGB stars. I'm Robert, my supervisors are Glenn and Knut, and in the next 10 minutes I'm going to tell you why it is that we think post-AGB stars play an important role in liner galaxies or early type galaxies or any galaxy for that matter. I'm using Khalifa data, and for those of you who are not familiar with that, with the Khalifa survey, here is a very brief introduction slide to the Khalifa survey. You see the Khalifa logo, and it shows you the hexagonal field of view of the PPAC IFU with its 331 science fibers. And here are a few numbers. So the Khalifa survey was initially set up to observe 600 nearby diameter selected galaxies. It has a spatial sampling of about 2 arcseconds. And with the low resolution grating that I use, I can cover the whole optical wavelength range, which is very useful if you want to use the BPT diagram, which I'm going to show you later. So, what are liner galaxies? Liners, by their very definition, are low ionization nuclear emission line regions, and we already know that that's not true. These are not nuclear. We see liner emission very spatially extended, and since their discovery in the early 1980s, the standard paradigm was that the ionization comes from low luminosity AGNs. But of course there are also other mechanisms to ionize the gas, such as shocks or the currently favored mechanism by post-AGB stars. And so your typical liner galaxy oftentimes is a early type galaxy rather than a late type. And we think that is only an observational bias because in these early type systems you don't have so much star formation anymore, which the radiation field from the young stars would overshine the liner signatures, and therefore it's oftentimes only seen in early type galaxies. Here you see example spectrum and the emission lines that are of importance when it comes to the emission line diagnostic diagram. You've probably seen this plot before with 85,000 SCSS galaxies here by Cooley et al. We can do the same thing with the Khalifa data. Of course it's less data points, but it very looks similar. And now comes the beauty of integral field spectroscopy. We can pick any galaxy in here and look at it in detail. And let's pick one from here. Take one Khalifa galaxy, and you see for this galaxy NGC 2916, it has again activity in the center and star formation in the outer parts. And maybe this diagram is not the best representation to look at it. I also show you here the BPT map. So in the center, again, you see the Seaford, the region classified as Seaford on the previous diagnostic diagram, and star formation in the outer part. Here's another example. You see especially very extended liner emission, and down here you have a scale compared with in this galaxy, and again also star formation in the outer part. And what we did in our analysis in Singh et al. 2013 was we took from a sample of 48 liner galaxies that we had so far observed within Khalifa, we took all the green spaxels, disregarded all the rest, and plotted for all the liner regions in these galaxies the surface brightness profiles. Here, normalized H-alpha flux as a function of radius, and it looks something like this. And these are the smooth profiles of these 48 galaxies. And we compared it to what we would expect from a single ionizing point source in the galaxy, which is here the black line. It's one of our squared profiles involved with the PSF. And before you start screaming, yes, there are simplifying assumptions in there, such as homogeneously distributed gas in a thin disk. But we also challenged those assumptions in chapter 3 of the paper, which hardly anyone reads. Um, and the results remained robust against them. And what you see is a large excess of flux at larger radii. So this tells us that the AGN only explanation is ruled out. Certainly there can be an AGN ionizing gas in the centers, but obviously not at large distances. I could show you dozens of different galaxies, but I only have a few minutes left. So let me show you this one example here, UGC 11680. Here's the SCSS image. Next is the BPT map. You see in blue, the blue traces the star forming spiral arm, and you have liner emission in between, and the core here is there you have AGN Seifert type. So this would actually not be classified as a classical liner galaxy because it doesn't have liner emission in the nucleus. What you see next is again the same plots overlaid, the blue-green speckles, but in the background you have the H-alpha equivalent width map, and we have already heard in the talk before, Roberto Cid Fernandez made that analysis where he found this empirical threshold at an equivalent width in H-alpha at 3 angstrom, where galaxies below that threshold are retired galaxies, and so completely devoid of star formation. And what we see here and in other galaxies is that the regions, green regions, which are classified as liner, especially correlate with regions of a low equivalent width, and you see that better in the next histogram here. Those liner regions are mostly all below 3 angstrom line, and that is just for one galaxy. I show you this now for 369 galaxies, and you see this quite nicely on this plot. So this is one piece of the puzzle which fits into that picture and corroborates the idea that liner emission is powered by hot old stars. Another piece is this one here, looking at the stellar ages. This is again the same galaxy, and you see in the center where the Seifert-like emission comes from, you have the oldest stars. Then the liner-like emission comes from regions which are on average 4.5 gigayears old, and the rest, the star formation, comes from regions which are younger, of course. And so on the last plot I want to show you here, it's the same thing as you've seen before, but now in a histogram, that on average, even though the liner here in red now and the star forming regions in blue overlap, they peak at different ages, and this is another indication that the liner regions are ionized by older, hot old stars. And I want to thank you and leave you with my conclusion slide.
Questions? Question?
I'm sorry, I'm a bit confused. The previous plot says that the liner comes from intermediate stellar populations, intermediate age stellar populations, but then you say that the emission comes from hot old stars. So, and the Seiferts are lying in the very old regions, at least in this particular galaxy. And I think this is, if my memory serves me correctly, the original paper also says this. So, how do I understand the liners going from hot old stars? I would say it comes from hot intermediate age stars, which would be typically intermediate mass AGB stars, lowish mass, but not, not 0.7 solar mass, 0.8 solar mass stars, but more like 1.1 solar mass, 1.2 solar mass stars. Those don't count to me as particularly old, those are sort of intermediate age.
Yeah, it is more intermediate, not the very oldest. And the very oldest you have in the center where you're looking through the bulge. That's why it's deeper.
I mean, it's not to say you don't have lots of very old stars in those other.
No, I understand that, but the mix of population is clearly different where the liners are. They clearly have more intermediate or younger stars in them, if these maps are to be believed, which I think they are, to be honest. So.
Comment on that. This is a selection effect in part. You can only see the liner emission as an unobstructed ionization field in those regions where no other mechanism dominates. So if you have secrets in the center, you also have this old or immediate, whatever you want to call it, not young star formation, old star ionization field all through the galaxy. But in the center, the secret comes on top of that and dominates. Outshines that radiation.
Then throw out the secret.
So then throw out the Seaford and also do this in older galaxies. Because this is clearly a galaxy with a much more complicated star formation history than you might find in a S0, for example, or an elliptical galaxy.
Sure, but you will see that in every galaxy where you're coming from.
You want to comment?
I agree.
Jay?
Sort of along the same lines. Of course, the diffuse ionized gas has a liner spectrum. If you look at the DIG, it's a liner-like spectrum. So, in that case, heating is just as important as the ionization source. And if you make a plot of gas density in a lot of galaxies, even the regular T300 like its ages ago, you find that you switch over to liner-like spectra and the electron temperature seems to go up. So it's also possible you have some confusion between the ionization source and the thermal structure of the gas going on. That has to do with dilute gas. I don't think it's fully understood. And that would be consistent with what you were saying about where you see this at lower frequency.
Yeah.
Can I make a comment overall about the last one where it talks about the liners? It just struck a chord with me, which is that people who work on early type galaxy evolution in general throw out the liners from their samples because they don't really know how to deal with it. I think that that's now a mistake. I think that's actually a very bad mistake at this point because if liners really come from AGB stars, we shouldn't be throwing them out because they're part of the normal solar population of those galaxies. So people who have made big claims from samples of early type galaxies throwing out the liners may have missed an interesting population of galaxies that may somehow modify their
And like half of
conclusions. Like half of them. So Jenny Graves' fantastic work over the last decade. Everything she's done, she's thrown out the liners in her samples. And that worries me a little bit after what I've just seen.
Or other people take liners in their AGN sample.
Yeah.
Yeah, so I think one should be very careful now about dealing with
Where
liners.
it's like 3/4 of the AGN.
So I just want, it's just I think these are cautionary notes that we need to be more careful about how we deal with our samples. So.
Okay. Thank all the speakers.